This is the alarm setup screen for the Criterion NDT ST-11 and ST-11R. Today I'm going to show you about all the features on this screen and how to set it up. To get started, I'm going to use my reference coil and my test coil that you can see over here on the left side of your screen. I'm going to be using some bar stock that are 4041 Rockwell, and I'm going to drop them into the coil and add them to the alarm buffer so that it can form the alarms around these good parts. First I'm going to balance. That balance light was lit up for a good reason. You hit OK once you've got your part in position. It is important to have the test position be the same on both of the coils, the ref and the test. And now I'm going to set the air point. So I've taken the part out of the coil, hit OK, and now the air point has been set. That sets the reference to let the instrument know what the coil eddy current signal looks like in the coil when there is no part present. So now I can start adding parts. I'm just going to add a pile of parts here and we'll see how it goes. You can watch the alarms as they form. Typically you'll add more than 10 parts, but this is good enough for today's video. At this point, I can either add more parts or hit Setup Complete and move to the Test Review screen to start testing parts. But Test Review is another video all to itself. Let's go down the list and see that persist here is the next thing to talk about. With a persist value set to 1, I get a single dot to represent where the eddy current signal is for each sample. So if I drop another part into the coil here, I can see that my little dot is moving around. That's the little yellow one, and that is a single sample. Every time that thing moves, it is another sample, another sweep all the way through all the frequencies. If I turn persist up above 1 to anything above 1, then I get a line drawn between each one of the samples. So right now it's displaying 85 samples on the screen, and it is drawing lines between each one of those samples. It gets kind of messy. It's not terribly useful for this demonstration, but if you need it, you've got it, and it goes up to 200. All right, next on the list is the part buffers. The part buffer is this number right down here. So I've got a bunch of parts added. I've probably messed them up because I just added a bunch of parts really fast. Actually, it looks like the cluster's okay. This one here is a little bit of an outlier, but let's talk about that. So since I did just add that part, I can go back and find it. There it is, part number 12. So these part buffers here, this is a maximum of 200, and it includes the added parts and the recycle bin. Right now there's nothing in the recycle bin, but I'm about to change that because this part doesn't belong. It's sticking out away from the group, and I'm going to remove it. Removing it puts it into the recycle bin, and there I can see that part 12 is in the recycle bin. There's still 14 parts in the entire buffer. It adds these two together. If I go into the recycle bin, oh, and by the way, in the added parts now I can't get to 12, so it's in the recycle bin. But if I go in here and I delete it out of the recycle bin, then it reorders the numbers. So now I have a new part 12. That used to be 13, now it's been pushed down. So that's how the part buffers work. Next on the list are the views. The change view button right here allows you to change between 3 different views in this test mode. I'm in internal test enable, so I have a few views available that are not available in other views, in other modes rather. This one is XY expanded. This gives you the expanded view of the entire air point along with the alarm cluster and the balance location right there. And that is on the screen for each one of these frequencies. The next view is just the air point, and if I turn persist back on, I can see that I've got no part in the coil right now, and so my air point is sitting right there. If I drop a part back into the coil, I see that that one disappears, and it actually added the part. There's part number 11 back in there again. Okay, the next thing on the list is the alarm shape. The alarm shape is either the ellipse, which is the default, or the polygon. The polygon is the new alarm shape that was added to the ST-11 when the R was developed. It's pretty sweet. The way it's formed is really kind of neat. It looks like a rubber band. When you reduce your adjustment all the way down, you can see that it wraps an alarm around the outside perimeter of the parts. So you can see that the parts that are being used for this calculation have a little extra circle around them, and that circle tells you what the adjustment is. It lets you see how it's wrapping around those parts. So that's kind of neat, and it's pretty much self-explanatory because of that, so I kind of like it. The ellipse is the standard ellipse. Nothing too special about that aside from being able to support what everybody was kind of used to seeing. The adjustment for this goes up to like 1,000. There's the max right there. So that's zoomed out pretty darn far. And if you go all the way in, you can't quite get to 100% because 100% would be having a part right on the alarm. Since these are good parts, you wouldn't want that because that would be a failure. So 110 is the minimum that you can set the adjustment to. The next thing on my list over here on the left is the trigger threshold. This is the test trigger threshold, this yellow double line around the air point. So the center one is just the marker for where the air point is. It's right dead center of that circle. The outer two rings are the test trigger threshold. They are hysteresis. That's why there's two of them there, is if you have a chattery signal and it's heading towards the air point, it triggers on the inside one. If you have a chattery signal and it's heading out towards the balance point, towards the alarm cluster, then it triggers on the outside one. That prevents false triggers. The reason this particular channel is yellow is because it is the trigger channel. So right up here it says trig, that is trigger channel, it's this one. I can change it to a different frequency, which is probably a good thing to do in this case because I did notice that one had a little bit of noise. You want your trigger channel to be the quiet channel. It's good to have it be one of the high frequencies, but you don't want it to be a noisy high frequency. The last thing on the list is temperature compensation. You can see the little temp comp symbol up here on the screen right above change view. That thing will flash. There it went right there. And that means that it has compensated for temperature drift. It compensates when the data sits back in the air point. So I can turn this on and show you that that's where that is. It basically just tugs the data point right back to the center of the air point when there's no part in the coil. And that compensates for temperature. If you'd like to know more about this, check out the manual. There's a full description in there. And if you'd like to reach out to us for any reason, we would love to talk to you. Thank you for watching the video. Please like the video, subscribe to the channel for some more stuff. Hope you enjoy our instruments. Have a great day. Bye-bye.